Good morning, all. Hi, hello. So, today we are going to see regarding the type of rock formation. So, in the earlier classes, we have seen basic introduction of engineering geology and what are the catastrophic failures that have happened without knowing the geological formation, and what are the types of dam failures that have been occurred earlier, and what were the failures that happened due to the failure in the structure or geological structure or in the earth, etc. So that we have classified into like a number of failures, like we have seen Baldwin Dam in the US, and we have seen few of our dam sites in India also, where how this geological failure creates such a big mishap and the failure of lives may happen. So it is very important for us to understand what is the type of rock formation, and this is the very important topic where a civil engineer must understand how and why this rock type of formation is necessary to learn. So specifically, we generally talk about granite, marble, sandstone, etc., etc. So what are these parental formation? How these rocks have been formed? What is the reason behind the formation of igneous rocks? What is the reason behind the formation of sedimentary rocks? What is the reason behind the formation of metamorphic rocks? So for a civil engineer, it is very important to understand what is the type of formation of these types of rocks. So before moving ahead, we will see what is igneous rock. Specifically, this session is going to be covered specifically on igneous rock in detail. So igneous rocks forms when hot molten rock crystallizes and solidifies. So this we might have seen in our earlier stages also. We might have seen this lava that due to some heating in the earth crust, due to high temperatures, with a sudden pressure, lot of some solid of heat mass is going to come on the earth surface. So the various elements that are present inside the earth surface, due to excess heat and pressure and temperature, at some part of the time the total soil, the mass, or the liquefied mass comes out and again it cools. So basically, when this particular hot mass is going to come on ground and getting cooled, they form in form of a rock like structure. So this is the various types, where we can see the stratovolcano. From deep inside the crust, there is some due to high temperatures, the passage of this the hot liquid, which is going to be converted again in form of rocks. So this is various spreading center, shield volcano, stratovolcano, etc. See, we can see here the earth crust is having some lot of mass which is boiling here, and here it is coming on the earth surface. We can see, and also we can see few earth mass that is coming on the ocean floor. So before that, we need to understand why this the importance of igneous rock has to be learned. Igneous rock, it is one of the hardest material when compared to other type of rocks. How and why these igneous rocks are having such a huge bearing strength or the load bearing capacity? What might be the reason? So the formation of these liquids for over years and years and years together of various materials, and they are crystallizing in such a way that at high temperatures they are liquefied, and again it is crystallizing, thereby the availability of various minerals and the composition of different minerals that are coming together and getting liquefied, and when they are coming on the surface or inside, they are getting solidified. This solidified hard structure is basically igneous rock. So the earth crust is 4 by 5th of igneous rock. Very interesting. About 80% of the earth crust is igneous rock. So what about these sedimentary rocks and metamorphic rocks? Yes. So every igneous rock life begins with a magma. That is what I was telling. The hot liquefied mass is called as magma due to the high temperatures and pressure at some point. Due to the high pressure, it might come to the near to the earth surface, or it might be cooled inside the earth surface only. As magma migrates towards the surface, some of it chills and hardens underground into various types of igneous rocks. So, when it is migrating to the earth surface, there is some different kind of type of rock is being formed, and some type of magma that hardens inside the surface, the lava surface itself. Magma that makes up to the surface erupts in either flowing or explosive volcano, generating lava or pyroclastic debris. So that is what. So it may either erupt in the form of explosive volcano, generating lava, or pyroclastic debris. So we will see more detail. So this is the quarrying that we can say that a big lump of rock mass is being quarried and it is being used further. We can see there are hundreds of cubic meters of rock mass that is available, and it is quarried and it is used for various infrastructural purposes. We will be seeing many a times that granite application, black basalt applications, sometimes of sandstone applications, etc. So the basis and origin that are basically in the type of formation is of igneous rocks. That a civil engineer must have an idea that how this particular granite or basalt rock has been formed. So what are the basis for the formation, etc. So many a times we basically see we see very big mountains. So can we assume that the those mountains that have been erupted over that place over 100 or 1,000 years ago? Yes, it might happen. So they have been erupted, or they might have transported from one place to other, and they have been cooled, and finally they have converted into big rock mass like structure. We call it as mountains. So again, to understand the type and formation of that materials or minerals available in that particular rock, again a detailed characterization of that material is very much mandatory to understand the age, to understand the composition of the rock, to understand the texture of the rock, to understand the age of the rock, etc. Next, so as I have already highlighted, igneous rocks are of two types, intrusive and extrusive. So what is this intrusive? It's very simple. Magma crystallized slowly within the crust. No exposure to the cool atmosphere. Magma crystallized slowly within the crust. No exposure to the cool atmosphere. So intrusive rocks are igneous rocks at which greater depth within the crust are mantle. So, in a general terms, we can say that this particular magma is being cooled within the crust surface or near the surface of the crust, that it has not reached the ground level. So, whatever the minerals that are present inside the crust surface, the minerals and the different combination of rock may form as a rock, strong solidified rock having different sizes of grains available in it. Now, what is this extrusive rock? So, an example of granite is an intrusive rock. What is this extrusive rock? Lava and pyroclastic debris extruded at surface or at very shallow levels. Lava and pyroclastic debris extruded at surface or at very shallow levels. Right. So that is what the previous examples we might see most of the times. So this hot lava or magma, the liquid, when it is reaching the earth surface and getting solidified and cooled, so that particular type is called extrusive type of rock. Particularly as a strong example is the black basalt, that we have common applications in our infrastructure. Basically, we go for flooring, and we also used for some the applications in the institutions, institutional buildings, etc., where you can find a very big application or surface areas. We go for that black basalt, which also gives some good aesthetic and good feel when you look at that particular black basalt type of stone. So this is an example. So a person, he this is an extrusive type of material. So once this particular material that is reaching the ground surface and it is getting solidified. So can we say this as intrusive rock? Yes or no? No. Why? Because on the ocean floor, this particular magma has reached the ocean floor, which is that the surface over there, and it is oozing out on the ocean floor and getting cooled at the same place. So this is again an extrusive type of rock where we name it as pillow basalt. So igneous rocks are named on the basis of their texture and composition. What we can say, that what is the meaning of texture? The soft or the rough surface that we can see on the surfaces of any rock. And what about the composition? What do you mean by composition? So the various type of minerals that is making the igneous rock a strong material where it has a very good bearing strength. So the minerals that are helping to create a strong bonding between the material or the other materials, they are the composition that we say. So texture is a rock of size. Texture of a rock is the size and arrangement of minerals that it contains. So composition of rock and assemblage of minerals. So as magma crystallizes, a network of interlocking minerals that develops. So we can see there are different minerals. Can we assume that this is some different type of minerals that are available? So the interlocking of these minerals make the bonding at some higher temperatures. After they are completely melted, this particular interlocking of various minerals making the granite such a hard resistive material. So the composition of and texture of a resulting rock is determined by these minerals. Basically, these minerals are of silicates, aluminates, etc. So these are the materials that are making this particular igneous rock or the various type of minerals a strong bonded material where we are taking an advantage of it and we are using for various applications. So, as we have seen, we can see some texture. What is this texture? That is what I have told, that the arrangement of the minerals, the composition is the availability of various minerals together. So we can see a large textured white colored mineral. Here we can see a large textured white colored mineral here. Again we can see some small black colored textured minerals that are interlocked or bonded together. These are the various minerals that we can see. So this particular type of rock is called phaneritic texture, which is having a large minerals. Example is granite. So this may not be all the times. This may not be at all the times. Why? Because this type of phaneritic structure, it may not. It depends on the availability of the grains at that particular earth crust, where the rock or the rock formation may be a fine rock or a coarse rock, or the fine grained or a coarse grained. So the large crystals had a long time to crystallize, therefore it is an intrusive rock. Example, what we have understood about the intrusive rock: whenever this particular liquid or the magma that cools inside the earth crust, it takes some number of the time very much higher when compared to the extrusive rock. The time taken will be very much higher. So that's the reason that's the reason where this intrusive types of rocks are having large type of minerals that are available. So earlier we have seen phaneritic structure. This is a phanetic structure which is having mineral grains too small to see with an unaided eye. So this particular rock is having many small minerals that we cannot see with a naked eye. Although it is a granite, one kind of igneous type of rock, where the composition of this particular material is having very fine grain like materials, whereas when compared to the granite that we can see, the large composition of the materials of different various types and shapes have been made the rock as a granite. And whereas here basalt, which is in dark colored, which is a basically an extrusive type of rock. So small crystals had a small short time to crystallize, therefore this is an extrusive rock. So this is again basalt. So what could be the reason for the formation of this kind of openings or some uh, honeycomb like structure that is formed in the rock? What might be the reason? So this is assumed to be called as basalt rock. So after the formation of this particular basalt rock, there might be some gases that have been evolved with the mixture of various other elements, where that particular gases create some air pockets inside the rock mass, where this air pockets, after removing the release of gas, it forms an opening at that particular place, and which we are calling it as honeycomb like opening. So, a fine grained, dark colored rock of volcanic origin, composed of primary of palyglass spelvar pyroxene together with other minerals, usually including olivine and limetite, and oxide of iron and titanium. Basalt is the most common extrusive igneous rock on the terrestrial planets and covers about 70% of the Earth's surface. So we can see the another type of example, which is an vesicular structure. So the gases again, they are so the many after escape of from gases, we can see this particular structure that is forming on the rock surface. So we can see propylitic texture with two distinct grain sizes, large and small andesite porphyry. So we can see different types of grains. So these are the various various grains that is making. Again, how can we determine whether it is an intrusive or an extrusive rock? So according to me, it might be an intrusive rock, and most probably it might be correct. So what might be the cooling history? We can see the large grains that are present inside the rock mass, and also that of different colors, right? So this is one type of texture. This is another type of structure where if we assume that the rock sample is very soft in nature, they are having a soft texture, they are also brittle in nature. So obsidian is produced from felsic lava rich in lighter elements such as silicon, oxygen, aluminum, sodium, and potassium. Obsidian is hard, brittle, amorphous, and therefore fractures the sharp edges. So, this is a glassy type of textured material, and it is also a brittle material. So, basically, when the lighter elements that are present inside the lava, like silicon, oxygen, aluminium, sodium, and potassium, they are helping this for the formation of this particular type of obsidian type of material. So no crystals, this is an extrusive rock. So felsic type of formation. So the composition of rocks, felsic, so intermediate, mafic, and ultramafic. So the composition of rocks are of again four different types that we have seen in the earlier sessions or in the earlier slides also, that I have seen. I have shown you that the arrangement of various grains are the minerals that are making the composition of the particular material. So we can see the felsic type of material, intermediate, mafic, and ultramafic. So the availability of oxygen, silicon, sodium, enriched iron, magnesium, calcium depleted. So this particular material is a felsic type of rock. Example, it is a granite. So intermediate is diorite, mafic is basalt, and ultramafic is pediorite. So it all depends on the arrangement. So we can only see the arrangement of the crystals But chemically and physically, the arrangement of minerals plays a crucial role in the strength characteristics of the material. And if there are other requirements for a civil engineer, so this particular different types of composition will help for understanding the what will be the various strength of the various types of rocks. So how does igneous rocks form in cooling magma chamber? So remember partial melting? Yes. So inside the chamber of the lava, we have told you that the lava is getting cooled by itself inside the lava chamber. So the silica, which is felsic type of material, compounds melt first. Therefore, in a cooling magma chamber, they melt. They must crystallize at the last. So silica is the most of the material that is present inside any rock material, which is a crystal. So silica compounds melt first. So how does the igneous rock form in a cooling magma chamber? So we have already explained that silica, felsic type of formation is a silica type of rock. So silica compounds melt first. So the melting point of it is quicker. So therefore, in a cooling magma chamber, they might crystallize at the last. Iron, which is mafic type of compounds, melt at the last. Therefore, in a cooling chamber, they must crystallize first. So the the felsic and mafic type of structures, first the materials which is melting is a silica, oxygen and sodium, whereas in the mafic type of structure the Fe, Mg and calcium. And at the mafic type of structure we can see in the melting point Fe, Mg and Ca, and the crystallization is taken by felsic type of structure, which is SiO and Na. So therefore the cooling magma will become enriched in SiO-A. Crystallization proceeds. So these are the various types of igneous rock forming materials, which is alvine, pyroxene, amphibole, biotite mica, polyclase, orthoclase, muscovite, and quartz. So these are the felsic minerals. These are the these are mafic minerals, and these are uh, felsic minerals. So I have already told you that the silica type of materials, which is having abundance of silica type of materials, they are the they are the felsic minerals. Example is quartz. One can remember pagiloclase, which is Ca and Na related, and mafic type of materials, which is iron rich materials, which are alvine, pyroxene, amphibole and mica, etc. So we can see intrusive and extrusive type of rocks. So these are intrusive rocks and these are the extrusive rocks. So all the rock family belongs to igneous rocks only. So it only depends on the type of formation, whether it is an intrusive rock or extrusive rock. So intrusive rock is again an igneous rock of different behavior, and extrusive rock is again an igneous rock of a different behavior. So application may be different, and the strength component may also vary between the type of intrusive and extrusive rocks. So, igneous rock is an unambiguous component of Earth crust because it evolves as a product of a tectonic processes. So, we can see I have already explained basalt, pillow basalt on the ocean floor, etc., etc. So, in the Earth crust, we can see the decompression, melting, ultramafic rocks of upper mantle. These are the hot spots, etc. So, when coming to the summary of igneous rocks are formed from molten rock. Igneous rocks are characterized by interlocking crystalline structure without preferred orientation. Igneous rocks are classified according to their texture and composition. So, the composition tells where the source magma came from, the texture tells how cool it is. A few composition of igneous rock are rather common and most possible composition are fairly rare. So the texture pumiceous, siliceous, tufaceous, glassy are immediately determine the rock name. So for pheneratic rock, you need to determine the mineralogy and use and type of rock name. For aphanetic rock, you need to determine the mineralogy of phenocryst and overall rock color and use those in determining the rock name. So the classification scheme used in this class is greatly simplified taxonomy. So we will see some of the other types of examples of igneous rock. Gabbro, which is an intrusive rock type of rock. Pegmatite, this is also an intrusive type of rock. Kimberlite and polyphratic texture, which is of different types. So these are the different types of igneous rocks and their types of rock formation. So in the next session, we will be seeing regarding the metamorphic and sedimentary type of rock formation, and you will be surprised to see and understand how this igneous rock plays a key role in the formation of metamorphic rocks and the sedimentary rocks. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.